In this lecture, we will talk about application of circle. Suppose that receiving stations X, Y, and Z are located on a coordinate plane at 3 points. 511 is X, so 511, X is 5, 1, 2, 3, 4, 5, 11, 1, 2, 3, until 11. So this point, 511 is X. Y is -7, -5, so -7, -5, 1, 2, until -7. -5, 1, 2, 3, 4, 5. See, that's right here. And Z is -5, +6. That's Z. So -1, 2, 3, 4, 5, and +6. So 1, 2, 3, 4, 5, 6 is right here. Okay. So receiving stations X, Y, Z are located at these 3 points, X, Y, Z, respectively. Now, the epicenter of an earthquake is determined to be 10 units away from X. So we know that the epicenter is 10 units away from X and also 10 units away from Y. So it's basically 10 units away from here and 10 units away from here. Okay, and then 5 units away from Z, from this point. The question is, where on the coordinate plane is the epicenter located? Now, we know the epicenter of an earthquake is 10 units away from X. We know here 511. Now we use this protractor. You see X, starting from X, this point, up to this far, the distance is 10. Because here you see 1, 2, 3, until 11. Okay. Then from 1 to 11, the distance is 10 units. Okay, so if you use this one, X, as a center, then all the points on the circle, you may draw over there. But you know, we don't need to draw over there. We know it's somewhere here. So, all the points on this semicircle are 10 units away from X. We also know the epicenter is 10 units away from Y. Y is here. So we may draw another circle with the center here on Y. And we did not change the radius. That's 10 units. So we draw another circle. Okay. It looks like it's somewhere here. Okay. Yeah. Where is that? You see. This point is 10 units away from here, 10 units away from Y. It looks like it's from here. Okay, so let's put -1, 3. right here, because here is -1, here is +3. So it's possibly this point. And we also know the epicenter is 5 units away from Z. And then, 5 units. You do is, the center is here. You measure 5 units. 1, 2, 3, 4, 5 units. And then you draw a circle. Yeah. All the points on the circle, on this circle, is 5 units away from here. Then it confirms the solution might be -1, 3, this point. Okay? But, this is the way you draw the picture. Is algebraically is really so or not? So you got to check. Let's put P right here, all right? P. So we say -1, 3. To check if this is going to be the solution. The distance between P and X, distance between P, this point, and X, how we are going to calculate? That will be what? Will be 5 minus -1 squared plus 11 minus 3 squared. Don't forget, choose the square root. Okay, now see what do we get. And then you have 5 minus -1, that's +6 squared, plus 11 minus 3, that's 8 squared. And then you have is 36 plus 64 together is 100. You choose the square root is 10. It looks like this is the possible point, -1, 3. You may also check the distance between P and Y. P and Y. Again, that's the square root. Is actually, let's do -7 minus -1. -7 minus -1 squared plus -5 minus 3 squared. Choose the square root. Let's see, what do we get? -7 minus -1, that's -6. Okay, squared. And -5 minus -3 is -8 squared. And then you do is -6 squared is 36 plus -8 squared is +64. That's what? That's 100. Choose the square root. So you then have a 10. The last one you want to check is the distance between P and Z. So PZ. You want to do is 6, or you may do -5. Let me write -5 minus -1 squared plus 6 minus 3 squared, and then choose the square root. Okay, -5 minus negative, so it's -5 plus 1, which gives us -4 squared. 6 minus 3, 6 minus 3, 3 squared. Choose the square root. And then you see down here, -4 squared is 16. Plus 3 squared is 9. I should not put square here. It's already squared. -4 squared is 16. So then you have is what? 25 inside. Okay. 16 plus 9 is 25, which gives us what? 5. So this point is the solution. Okay? Yeah, that's very important in application. Okay, I'll see you next time.